Question from October, November 21, 9709, variant 33. Question number 11. The complex number minus square root of 3 plus iota is denoted by u. A part, express u in the form r e raised to the power iota theta. This is called the polar form or the exponential form, where r is greater than 0 and theta greater than minus pi, less than or equals to pi, giving the exact value of r and theta. So here r is the modulus and theta is called the argument. So here this r is the modulus and theta is the argument of u, because u is the complex number. So the complex number is u. U is equal to minus root 3 plus iota. So for the modulus and argument, I can show you these notes. These are the notes on complex number, the basic, the concept of modulus and the argument. So if z is the complex number, not a plus iota b, if a plus iota b is the complex number noted by z, then the modulus formula is, the modulus of z is a square plus b square under the root, and argument of z is the angle, and it is greater than minus pi, less than or equals to pi. So the modulus, so you can associate a point to any complex number, and this is a comma b. So this a comma b, this point can be in any quadrant. So for the modulus, I give you this first, the example of the first quadrant. If ab, if the complex number, if ab is in the first quadrant, modulus of z you can find by completing, because the real part is a and the imaginary part is b. So by Pythagoras theorem, a square plus b square, this is the formula for the modulus. So the special case should be taken, must be taken for find the argument. As the quadrant can be, as the point can be in any quadrant, first, second, third, or fourth. So you will find the argument accordingly. So if it is in the first quadrant, if the point is in the first quadrant, argument can be obtained by simply tan inverse of b over a. If it is in the second quadrant, the formula for the argument is pi minus tan inverse of b over a. Tan inverse of b over a basically is this angle. If it is in the third quadrant, argument, the theta can be obtained by using tan inverse of b over a modulus minus pi. So this is clockwise, so angle is in negatives. So the last is the fourth quadrant. The formula for finding the, so simply keep these four rules in your mind. So if the first quadrant, simply tan inverse of b over a. If the second quadrant, pi minus tan inverse of b over a. If the third quadrant, simply opposite tan inverse of b over a minus pi. And if it is the fourth quadrant, minus, because clockwise, minus tan inverse of b over a. So coming to this question, a is, so yes, you can write minus root 3 comma 1. This is the second quadrant. So modulus r is a square plus b square. So this is a, this is b, is equal to minus root 3 square plus 1 square, which is equal to 3 plus 1. And so r is equal to 2. Minus 3, 1 is in the second quadrant. Real axis, imaginary axis. So second quadrant minus root 3, 1. This is the argument. So argument of z, which is theta. Theta is the argument of u, because u is the complex number, is equal to second quadrant pi minus tan inverse of modulus b over a. So theta is equals to pi minus tan inverse of b over a modulus 1 over root 3. 1 over root 3 is pi over tan inverse of 1 over root 3 is pi over 3. So theta is equals to pi minus pi over 3. So theta in this way is pi minus pi over, sorry, this is not pi over 3 but pi over 6. So this is 5 pi over 6, the value of theta. We have theta, we have r. So for the r, the simple formula is a square plus b square under the root. So in this we can find the modulus. For the argument, we need to identify the quadrant first, and for the quadrant you can simply associate a point to the complex number minus 3 comma 1. So this is obviously in the second quadrant, and for the second quadrant the rule was pi minus tan inverse of b over a. Yes, second quadrant pi minus tan inverse of b over a modulus. So after finding the value of r and theta, u, which was minus root 3 plus iota, can be written in the form, any complex number can be written from e power r e power iota theta. U is equal to r 2 e power iota 5 pi over 6. So this is the exponential form or the modulus or the polar form. This is the polar form. I can call this the exponential form of the complex number. And this was the requirement to write in the form r e power iota theta. Hence show that u power 6 is real and state its value. U power 6. As u is 2e raised to the power iota 5 pi over 6. So u power 6 is simply 2e power iota 5 pi over 6 with power 6. U to power 6 is 2 power 6 e power iota. So multiply the powers, it is 5 pi. 5 pi is not the, it cannot be the, because argument theta is greater than minus pi, less than or equals to pi. So if we just subtract 2 pi, it is 3 pi, again not in the range. 3 pi, this is a simple rule, minus 2 pi, so pi is here. So you can write u power 6 is equal to 2 power 6, 64 e raised to the power iota. So instead of writing 5 pi, because we know that the 5 pi, where is the 5 pi? 5 pi is here. So 0 pi, then it is 2 pi, then it is 3 pi, then 4 pi. So 5 pi is at this position, which is the position of pi. So pi, 2 pi, then 3 pi, and then 4 pi is here, then 5 pi. So instead of writing 5 pi, use that, and this can be obtained simply by subtracting 2 pi. If not in the range, again subtract 2 pi. So we have that value which is in the which is the required condition for the argument. So next is right pi. Next 64 e power iota theta is, we know cos theta plus iota sine of theta. So this can be written as cos of pi plus iota sine of pi. Sine of pi is 0 and cos of pi is -1. So u power 6 is equals to -64. The question was, show that this is real and the state its value. So obviously u power 6 is the real and its value is here. So u power 6 is real and its value is -64. Next, on a sketch, so this is how you can answer this part. So show that this is real and find its value. On a sketch on the Argand diagram, share the region whose points represent complex number z satisfying. So u is here. 0 is less than or equals to argument of z minus root 3 plus iota less than or equals to 1 over 4 pi, and the second is real part. So here this is the half line, end point of the half line is here. So the end point minus, as stated earlier, minus root 3, which is minus 1.73 comma 1. Somewhere over here is this point minus root 3 comma 1. So greater than or equals to 0, draw the line passing through. So this is one half line, angle is 0 with the real axis. The other is the line half line with angle pi by 4. So it can be somewhere over here. This angle is pi by 4. So greater than or equals to 0, less than or equals to pi over 4, with the end point -3 comma 1. So in between this. The second is real part of z is equals to 2. Real part of z is less than 2, is less than or equals to 2. So if the complex number is x plus iota y, then what is real part of x plus iota y? The real part of x plus iota y, this should be clear, is x. So this means x is less than or equals to 2. So x equals to 2 is line here, and this line is x equals to 2. This line is x equals to 2 and passing through obviously from 2. So where is the shading? Shading is here. So greater than this, less than this, and less than this line x equals to 2. So the shading is here. This is the shading. So question was, on a sketch Argand diagram, shade the region whose point represent the complex numbers z. So z is somewhere here in this green region, satisfying the inequalities. First inequality is here, the half line, two half lines in between these two half lines, and the other is x is less than or equals to 2. So we have the shading here. The last part is find the greatest value of z for the points in the shaded region. So z we know is the modulus. Modulus always starts from here. So modulus of z is means from this point we'll have to identify a point on this region whose distance is which is question is find the greatest possible value of z. So this point is here whose distance is greater. So this modulus starting from here, this green line. So question is to find the length of, so it's this black line, this line. How to find this length? So we have a triangle. In this triangle, this is the greatest value of z question mark. This length is obviously from this end to this end is 2. So we need one more length or the angle. So we need this length. How to find this length? So this height is 1 and you can find the length from this end to this end. So 2, and on this side it is root 3. This is 2 on that side. So the total length from this end to this end is obviously 2 plus root 3. So this length is 2 plus root 3. So 2 plus root 3. This length is 2 plus root 3. And further, this angle is 45 or pi over 4. This is pi over 4. If this length is pi over 4, so we have a triangle, an isosceles triangle. So these two lengths are equal because 45, 45. So this measurement is uh, 2 plus root 3 because the triangle is isosceles triangle and the lengths are equal. Next, you can find this length in decimals. So this length is, this is the calculator, 3.732. And this length is 1. So the overall, the length, the total length, this length is obviously 1 plus 3.732 is 4.732. So if the two lengths are there, this length is there, this length is there, and we are looking for the greatest possible value of modulus of z. So you can find this length by Pythagoras theorem. So z square is equals to Pythagoras theorem is equals to 2 square 2 square plus 4.732 square. Using calculator, 4.732 square plus 2 square, and the square root of this is 5 point. Finally, the answer for z is 5.1379 dot dot dot. We need answer correct to 3 significant figures. So 5.14 is the greatest value of modulus of z for points in the shaded region. Means this length. This is the greatest possible length for the modulus of z, and for all the rest of the points in this green region would be uh, less than this modulus. Thank you.